Welcome to today's video. I'm Andreas Hanuja and I love Mesh. This is the first video of our Meshmas Behind the Scenes series. Stay tuned for more. In this series we explain the technical background of our Meshmas experience, beginning with easy minigames and concluding with the most advanced gamification elements. We assume a basic Unity understanding, but if you find it hard to follow, reach out to us for questions. We are happy to help. In this video we're gonna focus on simple minigames. Via physical interactions you can add funny small elements to your environment, which are intuitive and need no further explanation to the user. For us, such small games are quick wins. They are simple to make and give a reason to explore the environment. One thing that is important for most physics-based minigames is the possibility to reset their state via a restart button. Especially with physics interactions, the user needs a possibility to recover from unwanted game states. So this is what we're gonna explore today. I quickly present you my configuration of the Jenga game here. You can pause the video and copy them if you want. For a deep dive into these components, please refer to my Hello Mesh video, where I explain simple interactions based on a chess example game. You can find the video in our I Love Mesh community. The actual games are all physics-based and rely on Unity rigid bodies and colliders, as well as basic mesh interaction, utilizing the mesh interactable setup component. Let us first select our button object and add some components to it. In order to add visual scripting, we need the script machine and the variable component, which is added automatically after adding a script machine. To make the button itself interactable, let's add the mesh interactable setup component. We can stay with the default configuration here. Lastly, to animate our button, let's add an animator, which we will configure later. For the script machine we have two graph settings, embedded and group. This configuration describes where the visual script is saved. Embedded can be used for very small single-use visual scripts, while group saves the script in an extra file, which we should usually use for better project organization. Let's create our file, give it a name and link it up. We can also give our script machine a name for good practice reasons. Welcome to the script graph editor. Here we can place and connect nodes to build up our logic. We start with a mesh interactable body is selected node. This node exposes the boolean value that holds whether the interactable body is selected. We connect the output value of the node to an on-state changed node. This node is provided by mesh and triggers a program flow indicated by the green arrow whenever the input value is changed. By wiring up the value to an if condition, we can forward our trigger just in case the object was actually selected. Without if condition, we would also trigger our logic on deselecting the button. We can finally group nodes for better readability. This is especially important for larger visual scripts. On the left of our editor we can see our graphs variables. Graph variables are like private variables that are just for the particular graph instance. Object variables are more like public variables that are, for example, exposed to our Unity inspector. Let's create a new variable that holds the reference to the parent object of our Jenga game. For resetting the game, we try to access a reset body transforms component on this parent object. This component saves the initial transform properties of our game and can reset them when being triggered. The only thing that we now have to do is wiring up this functionality to our previous program flow. When we have everything connected, we can again create a group for better readability. Here in the variables component in Unity, we can find our reference variable. We have forgotten to set a type, which we can either do in the graph editor or right here in the inspector. Let's link up the reference to our Jenga game parent object and double check that we have indeed a reset body transforms component on this object. Okay, let's enter play mode and try out if our script works. Our game looks a bit messy. Let's press the button. Voila, it resets as expected. We can now play a new round of Jenga. After the game, or if some of the users mess up the game, we can again press our button. What we are still missing is feedback on the button. Let's add an animation to our animator component of the button. Let's create a new folder for Better Project Structure. In this folder we create an animator and an animation clip. The animator controls which animation clip is played. The animation clip stores the wanted movement of our object. We can open the animator window and drag the animation clip right into it. We can then create a parameter for our animator that we can use to decide whether we want to play back the animation. To switch between playing and not playing the animation, we need a second state as our default state, which we will use while our animator should wait for input. From this state we can create a transition to our animation state and a transition back after the animation is finished. Now we can restrict our transition with the created property in order to play the animation only when the property is set. For the back transition, no modification is required. What now remains is configuring when the transition should be triggered. Our back transition should trigger when the button animation is finished, so let us set an exit time of 1 and an instant transition duration of 0 seconds. The button animation should play immediately, so disable exit time and set the transition duration also to 0. Now let us quickly record a simple animation. Open the animation window and select the button object. We want to animate the transform Y position, so press record and modify the value. Let's look at it in the scene view. Initially our local Y position should be 0. At the peak we can set something nice. The animation will handle the transition automatically. Finally set the Y offset back to 0. By pressing the play button we can see a small preview. I want more immediate feedback, thus I tighten up the time until the peak is reached a little bit. Feel free to experiment a bit at this point. Finally we have to trigger the animation in our visual script. So let's wire up our program flow to an animation set trigger node and enter the property name onClick, which we previously set in our animator. Let's test out the final reset button. We play a bit around and voila, the reset works. Also the animation works flawlessly. That was already the first video of this series. Stay tuned for the next part where we start handle more complex gamification elements. See you soon!